Next up, we have AnyLogic North America talking about digital transformation enterprise simulation within the AnyLogic ecosystem. Please give a warm welcome to John Yednick and Arash Badavi.
Thanks, John. Good afternoon, good morning, good evening, everyone. On our end, my name is John Yednick. I'm the Managing Director of AnyLogic North America. I've probably met a bunch of you over the years through many different conferences. With me is Dr. Arash Badavi. Arash, you probably know from many webinars and cases over the years. He is the head of our AI, a program lead of our AI here at AnyLogic, and also leads our technical team here in North America. Today, you've heard of some great cases for AnyLogic software, cases around strategic planning, predictive maintenance, etc., even model socialization, and quite a bit around digital twins. In this presentation, we're going to talk a little bit more on the concept of simulation-based digital twins, and we're going to elevate this thought process a little bit by using a new approach that we're calling enterprise simulation. Andre mentioned a little bit of this earlier in his presentation, so we want to broaden that scope just a little bit. For some of you, this might be a little bit rudimentary, but for others, it's kind of a new concept that's working quite well for us in being able to broadcast the use of AnyLogic simulation tools in digitization across enterprises. Now, we understand the use of digital twin is widely used, and we've heard a few cases already today, and you'll have a few more this afternoon, and you can see that it's a vastly different definitions. However, in this discussion, we're going to attempt to expand on the concept and how you can leverage AnyLogic's technology, what we're affectionately calling the AnyLogic ecosystem, comprising of the AnyLogic model editor and the model manager to accomplish enterprise digitization, exploiting models beyond the model developer and expanding their life cycle and leveraging the work in a broader capacity. The products we're talking about here are nothing new. It's stuff we already have in place. It's AnyLogic 8.8, which we call the model editor, AnyLogic Cloud 2.3, which we call the model manager. And the reason we do this is to be able to leverage existing technology that people are using today or expanding today, but in a new way that strategically, that we've done a strategic development around these ecosystems to become AnyLogic as the de facto standard for simulation-based digital twins. We've pre-recorded this presentation so we can pack everything in a short time. It'll be Arash in his infinite wisdom expanding on how we're using our technology today. So we will have this recording start shortly, but we will be available for answering all of your questions at the end. So if you could, producer, please start the recording.
Hello, I am Arash Mahdavi, AI and Simulation Program Manager of AnyLogic North America. In this presentation, I'm going to talk about how AnyLogic can help you and your organization stay ahead of the competition in the time of digital transformation. It is not easy to stay competitive and at the same time create real value in the current fast-paced market. Any business that wants to stay competitive is expected to consistently increase its efficiency using the best tools and methods. To accomplish this, it's a given that operations will move toward automation and decision-making processes will increasingly incorporate the use of simulation, optimization, and artificial intelligence. These stringent requirements have given rise to new ideas that increase visibility of the underlying complexity of businesses and at the same time provide sophisticated methods to help decision makers. These concepts have developed into jargon that many of us have heard countless times over the past few years, such as digital twin, Industry 4.0, digital enterprise, and so on. While many use these terms loosely, there is no doubt that the shared ideas behind these concepts hold the possibility of immediate and significant benefit for businesses. Nothing can compete with having advanced access to an enterprise-level digital embodiment of the business and processes that let you examine future possibilities. Digital twin is one of the most promising and fruitful components into the actualization of a digital enterprise. Now I'm going to talk about the definition of what we call simulation-based digital twin to establish a mutual understanding for the topics that we will cover in the rest of this presentation. I'm sure at this point we all have heard the term digital twin, and some of you might have worked on implementing different variations of this idea. Since there are different definitions of the digital twin, let's review the idea of simulation-based digital twin to establish a common understanding of the definition which we will use in the rest of this presentation. To do this, I'll use the graphic created by Dr. Borschev, which describes this idea very clearly. At the core, in a simulation-based digital twin, we not surprisingly have a simulation model. I will talk about the special characteristics of simulation models that are used as digital twins with more detail later. But in a nutshell, these models have deep integration with the real system that they represent. They can update their state with the current and up-to-date information and can be used at operational level to simulate the future states of the system. Looking at this graphic, you see that we can trigger the execution of the simulation model at specific times. At these moments, the current state of the real system is transmitted to the simulation model, which it uses to fully initialize itself. It then starts the exploration of possible futures by running experiments. As you can see in the picture, there are a variety of experiments that can be used for this purpose, such as what-if analysis, Monte Carlo, or even optimization. The type and time horizon of these experiments depends on the context and the objective of the digital twin. As the model can run orders of magnitude faster than the real world, it is only a short time before information is returned to the real system, where it can be visualized and monitored through some form of interface. In most cases, the feedback from the simulation experiment is reviewed by an operator or some automated system, which can either take corrective actions or raise red flags to the decision makers whenever a preemptive intervention is needed. The other point to mention is that the frequency of these simulation executions depends on the use case and objective of the digital twin. The only caveat here is that the execution time of the simulation experiment should be less than the period or the time interval between the trigger points. Now that we established a base definition of simulation-based digital twin, I'm going to introduce you to a new term, enterprise simulation, which extends this idea to a larger scale and at enterprise level. Okay, now that we have reviewed the core ideas behind different terms, I'm going to introduce you to a new one that we coined at AnyLogic, enterprise simulation. To a great extent, enterprise simulation can be categorized under the ideas of digital enterprise and simulation-based digital twin, but it has its own unique characteristics. I will define more clearly what enterprise simulation means in detail, but first, let me clarify our motivation to add yet another term to this already overpopulated landscape. Like any name or label, creating association between a name and a specific idea increases the mutual comprehensibility and efficiency of a conversation. Because of our unique position as a technology provider and our access to a large number of the world's leading global companies, we've been able to identify distinct patterns in the usage of simulation across large multinational corporations. This distinct pattern that we call enterprise simulation has the following characteristics. Number one, the objective of enterprise simulation is to create many simulation-based digital twins that represent the interconnected nodes or components of a distributed business. You can visualize these nodes or components as hundreds of branches of a fast food chain, data centers of a technology company, warehouses of a retailer, charging stations of an EV manufacturer, or fulfillment centers of an e-commerce business. Number 2, each node or component of the business would be a digital twin of that particular unit. The models representing these business units are different in details, but all share a common business applications. For example, each restaurant branch layout, menu, and order patterns are different, but they all use similar equipment, procedures, and follow the same overall business model. Number 3, all models that are twins of each business unit are deployed on servers. These models are accessible by the relevant decision maker that may need to know about a particular unit, a segment, or the entirety of the network. Level of access to the nodes is managed and maintained by an administrator. Okay, let's step back for a moment and explain the enterprise simulation from a different perspective. When we only have a digital twin of just one unit, for example, one warehouse, one fulfillment center, or one restaurant branch, enterprise simulation would be synonymous with digital twin. So if you are not thinking about creating a federation of digital twins, you can imagine that the term enterprise simulation and digital twin are interchangeable for the rest of this presentation. How and when an enterprise simulation is implemented can vary greatly based on the needs of your organization. Even if you plan to deploy hundreds of digital twins associated with hundreds of distributed business units, you will most likely do that incrementally over multiple phases. This means that you will start by having digital twins of a few important or pilot nodes and then over time grow it to many other locations. Eventually, these models collectively will form into what we call the enterprise simulation. As you've now heard, creating enterprise simulation or digital twin is not an entirely unfamiliar concept. But at the same time, they have some characteristics that separate them from conventional simulation projects. Now I'm going to dive a little bit deeper into this topic from the perspective of the experts and modelers who are going to create and deploy these set of digital twins that compose the enterprise simulation. As I said, my target audience for this section are simulation modelers, and my objective is to further explain the differences between regular and enterprise simulation. Let's first think about the level of planning or decisions that are attributable to digital twins. Conventional simulations traditionally stay between a strategic and tactical level and rarely are designed to behave as an operational decision support system. In contrast, the idea of a digital twin, and in a larger context, a digital enterprise, is to provide on-demand monitoring, planning, and prospection tools. So in short, it is a requirement for the simulations to perform at operational level when we are using them as digital twins. Okay, now that we established that the models that are digital twins are primarily operational, let's review the ramification of this core requirement. The simulation lifecycle can be imagined as two main phases: creation and use or deployment. Creation is comprised of iterative tasks such as conceptual modeling, logic coding, data integration, and debugging. Model deployment, particularly in the context of a simulation-based digital twin, comprises of running the simulation models on servers and interacting with their outputs through a visual medium such as a dashboard or a control tower. Let's now take a closer look at the differences between the development of conventional simulation models and ones intended as digital twins. Let's start by the creation phase. The creation phase is very similar to regular simulation modeling, but with a few requirements. As I just mentioned, models that are operational inherently need to incorporate more details and are at a lower level of abstraction. In the case of enterprise simulation, when you are creating a large set of simulation models, there are typically logical components or layouts that are shared across all of the models. Models have deep integration with external data sources such as databases and sensors. These streams of inputs are almost entirely accessed remotely, meaning that a static snapshot of the data is not imported into the model, but instead the model can tap into up-to-date or live data from the real system. The models are created with deep parameterization so that the live data from the real system can be used to initialize or update the inputs whenever it needs to update its state to mimic the real system. The deployment phase of the model lifecycle has its own set of nuances as well. Most conventional simulation models are run locally, and the results are only accessible by a few analysts who have access to the models. In contrast, digital twins are more often run on servers so that they are accessible by all the stakeholders who are more often SMEs of the simulant rather than simulation modelers or analysts. Since conventional simulation models are accessed by a limited number of simulation experts and analysts, creation of intuitive animations or dashboards to showcase the results is not critical. For models intended as digital twins, though, an intuitive interface is a key requirement, and in some cases, this involves integration of the simulation output to an existing interface or a control tower. Running simulations on servers that are accessible by many people with different needs, both in terms of level of access and complexity of experiments, is not easy to set up. A proper deployment environment would need to manage a lot of intricacies that may not be obvious at first glance. Not all digital twins are monitored or run by human operators. It is very likely that some part of the decision support system will be required to automatically trigger simulation runs based on a predefined time intervals or conditions. These type of automatic triggers can only be executed if we have API access to the simulation-based digital twins. I mentioned the importance of customized interfaces for a digital twin. Utmost flexibility in this regard is needed, and having access to a variety of APIs can make this possible. Now that we discussed some of the key differentiators between conventional simulation models and the ones intended to be digital twins, let's hear about why the AnyLogic simulation ecosystem is by design a unique solution for the creation of simulation-based digital twins or enterprise simulation. We talked in detail about the required and desired attributes of simulation-based digital twins. I want to add a few words about how the AnyLogic company has strategically developed and architected its ecosystem for this specific application. As we discussed, there are two sides to the life cycle of a simulation-based digital twin: model creation and model deployment. From the model creation side, our original philosophy in creating AnyLogic was to shatter the boundaries both in terms of simulation methodologies, data connectivity, and interoperability with external tools and assets. AnyLogic Model Editor or AnyLogic Desktop has been synonymous with scalability and extensibility in the simulation market, and we've kept that momentum by, among other activities, establishing new standards and workflows between simulation and artificial intelligence. Our success in establishing simulation for generating synthetic data and meta models, embedding trained ML models into simulation logic, and using simulation as the train environment for reinforcement learning drove many successful projects in the past few years and forced other technology providers to follow our lead. Going back to the simulation lifecycle, we at AnyLogic have been quite aware of the limitations of running simulation models in localized environments. AnyLogic Model Manager or AnyLogic Cloud was our forward-looking project to provide a solution for the consumption of simulation models across the enterprise. We are delighted that our vision of the future is coming to fruition. We are confident that we have all the tools to help businesses in their digital transformation journey. Within our software ecosystem, the idea of a digital twin or an enterprise simulation that provides live feedback to a control tower is no longer a conceptual vision. Now I will give you a brief tour of unique technical features in AnyLogic's ecosystem for the entire simulation lifecycle. So far, we discussed the conceptual differences between conventional simulation models and digital twins, and how we strategically developed our ecosystem to provide a comprehensive set of creation tools in conjunction with a deployment and execution platform. Now I'm going to talk about this technology stack with a little bit more detail. In the creation realm, the AnyLogic Model Editor, the desktop application used to create and edit your models, has some unique characteristics that makes it an unmatched creation tool. The Model Editor provides access to the main three simulation methods under one umbrella, increasing your flexibility in building operational level models. Especially when you are working with low abstraction models, which inherently have more detail, any complementary tool in your toolset increases your chance of success. Operational models are inherently more complex, and multi-method modeling can help you deal with it with more elegant, modular, and object-oriented patterns. AnyLogic's editor allows you to implement external access in almost all parts of your model logic. You can incorporate external APIs, databases, libraries, optimization solutions, custom algorithms, or heuristic to your model logic. These external connections let your model to incorporate all types of logic or feedback at any level. This is exactly what you expect the simulation's role to be in a digital twin, as it's expected to serve as the centralized location for which all knowledge sources of the system converge to represent reality. The editor gives you robust interoperability with AI solutions, such as embedding of trained ML models into your simulation. This is a key factor in replicating hybrid systems of the future in which AI would play a significant role in their overall behavior. One of the unique capabilities of AnyLogic Model Editor is the possibility of creating custom parameterizable objects that can then be aggregated into custom libraries. Modelers can share these libraries with their team for future projects. As we discussed, recycling and reusing of common or generic elements of the model is a key factor in enterprise simulation, wherein you are creating hundreds of simulation models that have significant overlap. The custom block or logic that you create in the model editor would behave like adaptable pieces that can be used in several models. This approach lets a few advanced modelers to focus on creating the underlying complexities and expose a simpler interface for other modelers in the team to easily change or tweak its behavior without needing a deep understanding of their inner logic. This approach is a game changer in scaling your enterprise simulation when you have to create figurative model factory line that needs to pop out hundreds of models. Since the editor's front end uses a browser-based approach, it gives you the unique capability to see an identical visualization for your models regardless of running them locally, let's say during the development phase, and when you deploy them on servers for remote access and execution. Moving to use and deployment, AnyLogic's Model Manager is the only real solution available on the market that lets you seamlessly deploy models that are created with its editor. This fact alone is enough for this section, but let's go over a few of its features and functionalities. The process of uploading and deploying an existing AnyLogic model from editor to the Model Manager is done in a few clicks. Model Manager provides access to the exact same visualization and interactivity as the local runs. It supports Active Directory and LDAP, which helps the IT team to easily manage all the end users who can deploy and possibly manage your digital twins. There are different levels of access that can be set up for who can see or run certain models. For example, you can assign run-only access or development privileges, on a per model basis to people based on their intended use. All the external connections that you've established in the model editor would transfer to the uploaded or deployed version of the model on the server. Model Manager provides several different mechanisms to get access to the model outputs, including automatically generated Excel files, JSON files, and any files outputted from the model itself. You have access to all previous versions of an uploaded model, providing a secure archive of a model's changes over time for future reference. And as we discussed, you have API access to all of your uploaded models. The extensive API allows programmatic experiments and interactivity with models, opening up easy paths toward all sorts of fully customized interfaces to the digital twin that are deployed on the Model Manager, such as mobile apps, custom websites, or integration into visualization or BI tools. Now that we had a tour of simulation-based digital twin, enterprise simulation, and AnyLogic ecosystem, I want to talk for a few minutes about how we can help you and your team to turn your digital transformation mandate into a reality. I'll separate the help that we can provide into two parts. Number one, establishing the simulation ecosystem and workflow support. Our solution architects can help assess your team's simulation needs and create a software solution that effectively covers all of your current requirements and also to lay out a path for your future growth. Our team then will work with your IT to set up your simulation ecosystem, comprising of AnyLogic model editors and a model manager. To help your team to get up to speed with our software, we include a suitable training program into your solution that covers a wide range of requirements, from standard to customized training, project scoping, and roadmap architecture. After we get your team started on the right track, our technical support team are always available to help you with all types of technical questions. Number two, resources for ongoing help. At any point in the process, if you decide that your team needs more extensive help, we will connect you with one of our world-class consultant partners. We are in partnership with a diverse set of consultants, all with different specializations and resources. We make sure that you'll get connected with the right consultant depending on your short and long-term needs. And regardless of your scope, we have the right partner for you. This could be anything from short-term assistance, on-demand hand-holding, or the turnkey creation of large-scale simulations or global digital twins. To get in touch with us, please find the designated channel in your region from our website at anylogic.com under the Company tab and then Contacts. Now at the end of our discussion, I want to thank you all on behalf of the AnyLogic company. We really appreciate and value your trust in us and our products. Our goal is to always provide the best possible solutions for our customers and to provide the best possible support for our community. Thank you again for your time and attention.
I hope you could see that what we were talking about here in this presentation is more of a vision, and it is a little bit high level, but what we were presenting here is something that has worked consistently for us here at AnyLogic, where we are combining our current technologies, AnyLogic 8.8, AnyLogic Cloud, which we call the Model Manager, 2.3, I believe, or 2.2 at this point in time, where they have worked strategically in solving the business problems of our clients in this more enterprise simulation ecosystem. And I hope you'll see too that this combination of these technologies and the way they're deployed is in line with what Andre was speaking about earlier with AnyLogic 9, combining and pulling together AnyLogic development environment with AnyLogic deployment environment, which would be the cloud and the model manager. This vision is working for us with global companies right now, as well as smaller firms. So it's not something that's very large, yet, or can be something very large with large enterprises, yet something that works very small with smaller companies. So with that being said, let's get to a few questions. First one that comes up, can the model manager be installed? Is it a SaaS product? First of all, is it a SaaS product? The answer to that is no. The way we're talking about here is we are deploying the model manager along with AnyLogic model editor behind your own firewall, within your own infrastructure and IT infrastructure. And it can be deployed across multiple service providers like Azure, AWS, or even Oracle. We've tested them across all of them, and it works quite well. We've got documentation that supports on all of that. Let's see. Let's hit another one. How can currently have deployed digital twin cloud, Maria? How easy is it to go from a local AnyLogic model that we currently have to one that is a digital twin on the cloud? Great question. So right now, currently, if you're using them behind your own firewall, you've developed models on AnyLogic 8. Whatever, 8.x, and even previous versions. Through the simple, as Arash showed, click export the model. It gets deployed into the AnyLogic Cloud Model Manager. And then you can do all the standard things you can do with the Model Manager that we've shown, Gregory has shown in the past, and so on and so forth. So yeah, it's an easy migration. Which really is more, and then of course you get the advantage of all the additional things of AnyLogic Model Manager, like open APIs, the ability to run machine learning connections into the models, as well as do rate training, and reinforcement learning. Let's see. Let's see how I practice. I'm going to let Arash take this next one. Where how do you see it as it relates to CI/CD practice and tooling such as Jenkins? Can you answer that one, Arash?
Yes, John, if you don't mind, we are at the time, so
okay.
we're gonna cover that in a follow-up. But as you all know, everything that we showed is gonna be available in the follow-up, so you get a high-quality version of this presentation if you're interested.
Yes. Feel free to cut me off.
Yeah, thank you.
All right.